Cheers everyone, Cloudfather here. Today we're analyzing some problems. This will be hard to see, but if you look down here, let me see if I can get my camera to focus where I want it to here. So we're looking at the rail here, and you can see if I can zoom in a little more. See these black marks and pits? This is why I'm getting wobble in my lasing. So we've had to basically pull the laser out of the chassis here. And we're also going to replace the wiring harness. Part of the problem I was having, the laser wasn't firing reliably. It had blank spots in the x-axis. So the wiring harness, probably right here, has got a bad piece of cable in it. So the other thing that's really important here is this x-axis is very difficult to clean. You really got to work at it to get in there and clean this, and it needs to be done daily. Because it collects all kinds of dust. I mean, I take good care of my laser. I clean it constantly. I don't see any wear in the belts. These belts are 9 months old, so they're pretty normal. But you know, I think those will go the distance for quite a while. But there's a fair amount that you had to remove to get all this together. Okay, we've got it out finally. And you can definitely see a wear pattern right here on the x-axis. And the problem is, how do we get this rail back out of here? Because if you can't get this rail out, this laser will never run correctly again. Ideally, what I'm going to try to figure out how to do is to take the rail out, and then I'm going to roll it probably 90 degrees so it has a clean, smooth surface, and that will fix the wobble. The other area that is really a problem is the eccentric is not, you can't unloosen it. It's got the set screws out, and that can't be turned. The other thing is you can't remove from this block these pulleys, all of which have wear. And this is from a laser that is cleaned and oiled daily. We don't skip on maintenance. So this is a real problem. So at least I know why I was getting waverly lines. It's all right here. This bar is just worn out. This needs to be designed so you can basically pull it out easily and rotate it. And that way you can probably get at least several years out of a single bar. As it sits now, you're basically looking at having to replace the entire X assembly except for the belts and the drive and the limit switches. So that's a problem we need to figure out, because right now it doesn't make sense to even put the laser back together if I can't get these parts fixed. Now the next part of the problem is either right here or right here. What the laser's doing is it's going partially through the bed, and then it stops lasing, then it starts lasing and stops lasing. And so either there's an intermittent connection up in here, and this, by the way, is horrible. This should have never been done this way. This should have a TPU shield on it. This should be a single block connector. These are about the worst possible connectors that could be used. They're guaranteed to break, especially at the top here. This one at least has a cover over it, so it's not as susceptible. These aren't good either. The top one should have been heightened right angle. That would have taken a lot of the stress out. That's the limit switch. It's okay. Down here in the corner is another place where there's a lot of stress from constant moving in the x-axis, and it's the x-axis is breaking. The reason for that is the x-axis has far more motion than the y-axis, because typically you go through and do a x-pass back and forth, and then you do an increment of y, but it's only, 0.01 mils or something. So again, there's some real problems with this. This outer shield's okay, but the entire wiring harness should have been made out of Litz wire. And it should be super flex. This is just cheap cable. Guaranteed to get brittle, which this has done. And it's also very difficult to put these connectors in, particularly if you have it in an enclosure. So those are some things we need to talk about. Okay, Cloudfather here. As you can see, we've started putting together the wiring harness. This is the Z-axis. This is the Z-axis stepper. And that little guy right there, see if we can zoom this, is the Z-axis upper limit switch. I haven't had any problem with that, and it's pretty well protected, so we're probably good. Now, getting the air assist tube in with the wiring harness, it's a real struggle. So you kind of have to just work it in a piece at a time. What I did on the other end is I simply used wire ties to put it around the other end. That'll give me just as good a protection, but it actually puts less stress on the cable because now the cable's sitting freely within the cable cage. So we put the mounts back on, and then in here we're starting to mount the exhaust intake manifolds. This will dramatically improve the airflow. So a much better design than what I had before. And of course these I'm printing on my printer. So these are set up for 120 millimeter fans, but this is just going into a plenum that has an 8-inch axial blower on it for 1600 CFM. Now on the other side, we're basically going to do the same thing. So over the next day or so, I'll get all that put together. I'm still working to find out how I'm going to remove this rail. I want to replace this, so I've got to go find the material. Then I'm probably going to have to go to a machine shop and build a tool. As far as the rest of the chassis goes, other than the wiring harness and the fact that these eccentrics are not adjustable, if I can get these out without destroying this, which is a problem, I'm probably going to have to take liquid nitrogen and freeze it. I can't heat it because that would destroy the finish. But with liquid nitrogen, I might be able to freeze that down. That's probably also how I'm going to get these rails out. Because as you can see, these rails, unfortunately, are really toasted. And that, of course, causes all kinds of problems because every little bump on there causes an image problem. Now, the other place that is a problem on these lasers is the drive gear right here. and this has a round shaft. If it had two bevels on it, then it would never slip. So I've got to check the tightness of all of these, top and bottom, and also at the actual stepper for the Y. Now, these connectors are very important. So this is the Y stepper connection. This is the controller signals, which goes to the X-axis, and the limit switches. This is the power supply. This one with the little dimple on the end, this end, is plus 36, grounds in the middle, and that's laser power, which is between 1/10 of a volt and 3.3 volts usually. And of course it comes out here. Now this part right here, I'm going to take my die grinder and cut this off. This is really a mistake. I may eventually build a wire harness that plugs in here that allows me to take this box and put it elsewhere. In fact, really not even on the gantry, because it's actually in the way for everything you want to do. This is the Y limit switch. And on the X-axis, if we come down here and we look, if you look right in there, let's see if I can get a little more light on there. But down there is the X-axis limit switch. So if we can get these upper and lower rails out, and you can see here on this one where the rail, the finish is just coming off. It's absolutely hideous. That thing gets cleaned at least once a day, and it's still dirty. And I'm using what I would use for a really expensive gun to clean it with. So that's something I'm talking to Atomstack about. Hopefully I will hear from them in a day or two. Because it's quite important to be able to service your laser. And it would be ridiculous to have to throw these extrusions away because you can't remove the rails. So that's part of what I'm going to be working on for the next few days. I've made lots of cute little things for putting tools on and so forth. So I'm getting a good collection of those. I'm still pretty happy with the bed in here. As you can see, these are all going to get mounted like that. I'm probably later on going to modify these and put louvers in them so I can point the air whatever direction. But for now, this will cover pretty much the whole thing. And when you consider the cross flow, that's actually going to work out pretty effectively. So the original flow collectors are these guys. These are just prototypes made out of wood. Just stuff I had sitting around. The problem is it didn't shape the air properly. So I did a lot of reading and digging to see what needed to be done. The other thing is, this is the laser head with the newly finished, this is the blast shield plate. It's got the window for the flame detector. And then this is the new upper module, basically the filter for the fan. It's two pieces. There's a fairly dense filter on the bottom, and there's a fairly diffuse filter on the top. And between the two, they actually do a very good job of keeping this clean. And the other thing is I put a wall in by the connectors to make it easier to get the connectors in, but it also keeps the foam in place, so I can leave it with the top open if I want to. I am going to put screws across here. I just haven't done the CAD work yet to put the plates in. But the basic design has worked very well, and you can't really see it, but underneath there there's a shim right here, and that shim gives the 7.5 degree tilt that I've been talking about. And I have not had to clean the output lens of my laser in 6 months because of that shim. It deflects the beam just enough where it hits the cone. It doesn't hit the, doesn't go back up into the laser and overheat it. So that's been a really good mod. So we'll come back in a few after we've got a few more things printed out and put together. Alrighty, we got 3 of the 4 done. This is the exhaust side that's tied to that 8-inch fan. And as you can see, we have all 4 of our new intake air directors put in. Although I did discover I have a fan that's weak, so I'm going to have to go find another one. But that's pretty much it for today. We went through and redid everything here, put in a new plate. So we have a little neater looking inside. But I'm really pleased the way that came out. Hopefully we'll get the laser running here soon. Again, this little problem is really sad. This should be able to turn around. Unfortunately, somebody at the factory glued it in. So now I get to wait 15 to 18 days for new parts. So I'm sure we'll get them. It's just a question of when. Also built myself a little exhaust fan for soldering. That's 100 CFM, so it'll move quite a bit of air. So that's all for tonight. Had a nice pretty sunset. Cloudfather out.